Hello, friends. Today's lesson, lesson 17, is building on lesson 10 and lesson 14, some of the logical stuff, right? So building up this idea of logic, how it works. Um, and so conditional statements is our fundamental idea, the idea that we can make a statement if P, then Q, where P is some basic statement. We call that the hypothesis, and then Q is the conclusion, hypothesis conclusion. If P, then Q, that's kind of considered our original conditional statement. The converse, which we already talked about, is when you switch, right? Because a con likes to switch his identity. That's how I remember it. So a converse says if Q, then P. So for example, if today is Tuesday, then tomorrow is Wednesday. That's the original. The converse would be if tomorrow is Wednesday, then today is Tuesday. Now, there's an idea called negation. In negation, we are negating our statement. So, for example, if not P, and the symbol for not is this tilde, kind of a squiggle. I have seen it in some logic textbooks as like a negative sign, not, but for this context, we're using the tilde, that little squiggle. This means not P. So, for example, the statement today is Tuesday, not P would be today is not Tuesday. It's a very simple idea, right? This idea of negation. With the idea of negation, then, we can take our conditional statement and negate both the hypothesis and the conclusion. So the inverse is when we negate the hypothesis and the conclusion. So for example, you say, if not P, then not Q. That would be the inverse. Okay, so converse is switching. Inverse is negating both the hypothesis and the conclusion. So for example, right, if today is Tuesday, then tomorrow is Wednesday. That's the original conditional. The inverse would be if today is not Tuesday, then tomorrow is not Wednesday. This statement happens to be true. But the inverse is not always true if the uh, if the original conditional is true. We'll look at some examples later. However, the inverse is logically equivalent to the converse. If the converse is true, then the inverse has to be true. So for example, if tomorrow is Wednesday, today is Tuesday, this is the converse of the original conditional statement that we've been talking about. Now, there's one more variation, I guess you could say, and that's the contrapositive. This is where we switch and negate. So you could think of it as the inverse of the converse or the converse of the inverse. Either way, contrapositive, the way to remember it, contrapositive is a long and convoluted word. It's longer than inverse and converse. And so this is where we do both things. We put it all together, contrapositive, right? It's a lot of stuff. So we're doing both things, inversing and conversing. So it would take the form not Q, therefore not P, or if not Q, then not P, or not Q implies not P, right? This is the arrow, means if then or implies. The best language to use is probably just the if then. So we stick to that. The contrapositive is logically equivalent to the original statement, right? To the original conditional, you could say. And so here's a table kind of summarizing it. We have the original statement, if P then Q. Let's take this statement now. If it is a dog, it is a mammal. Right, so we're going to look at this one now instead of Tuesday and Wednesday, which is true either way, right? If tomorrow is Wednesday, then today is Tuesday. This one is a little different because we could say if it is a mammal, it is a dog. That's not true. We can illustrate this one with a Venn diagram. Are you familiar with Venn diagrams? If this circle represents all mammals and this circle here represents dogs, then the original conditional places this object in here, right? If it is a dog, then it is a mammal. That's true, right? If it's in this circle, it has to be within the bigger circle as well. The converse, however, is not true. Notice it says if it is a mammal, it is a dog. In that case, right? If it's a mammal, it is a dog. Well, not necessarily, because if it's a mammal, it could be here or it could be here. It could be in either place. So that statement is not necessarily true. The inverse. If it is not a dog, it is not a mammal. That one also, if it's not a dog, it could be here or it could be here. And so that one also not true, right? The contrapositive now Let's see what this says. If it is not a mammal, so if it's not a mammal, it's got to be outside of the mammal circle. It is not a dog. That's true. If it's outside the mammal circle, it has to be outside the dog circle. Okay, and so we see that the original and the contrapositive are logically equivalent, and the converse and the inverse are logically equivalent as well. So, continuing our introduction to logic, which is great. I think everybody should take a logic class. And for most people, geometry is kind of the only introduction they get to it. So, learning to think clearly is extremely important. Thanks for watching. Don't forget to like and subscribe.